Welcome to The Explainer. Today, we're unpacking a really high-stakes race happening just over our heads, the constant battle to defend our skies from a whole new kind of threat. I mean, think about it. You've got these drones. They can be tiny, incredibly fast, and they can come at you in swarms. So, how on earth do you stop them? It's a massive challenge, and the answer isn't just one thing. It's a whole process. A chain of events built for the speed of today's conflicts. And that process has a name. It's called the Counter-Unmanned Aerial System Kill Chain, or CUAS for short. Now, this isn't just about a single weapon or a single sensor. No, it's a complete end-to-end system, a concept taken from traditional military strategy and then adapted for this very unique modern problem.
The best way to picture it is like a digital immune system for our airspace. It's not just some static wall. It's a dynamic, living defense that's constantly watching, designed to find, identify, and then neutralize a threat long before it can actually do any damage.
So how does it all work? Well, this kill chain follows a very precise playbook. It's a sequence of steps that takes you from that very first hint of something in the sky all the way to the final action. Let's walk through it. Everything, and I mean everything, starts with detection. You can't fight what you can't see, right? And because no single sensor is perfect, the system uses a whole suite of them. You've got advanced radar painting a 3D picture of the sky, RF sensors that are literally listening for the radio chatter between a drone and its pilot, high-tech cameras, that's the EO/IR, that can see in both daylight and total darkness, and even acoustic sensors listening for that signature buzz of drone propeller. Okay, so once a blip pops up on the screen, the intelligence phase kicks in, and it happens fast. First, the system has to track it, locking on to know its exact position and speed in real time. Then, it tries to classify what kind of drone it is. Is this just a regular off-the-shelf quadcopter or something more dangerous? And finally, it has to identify its intent: friend, foe, or just neutral. This is like a rapid-fire investigation to turn that little dot on the screen into a confirmed threat.
So how does it make that call so quickly? Well, it checks the drone against what are called Blue Force tracking systems. Think of it as a digital friends list for all friendly aircraft. It can sniff out unique electronic IDs, like a MAC address, and check it against a known database. And here's the kicker. It uses AI-powered visual recognition to analyze video feeds and make that final crucial confirmation. Yep, that's a hostile.
And the speed of this whole thing is what's truly mind-blowing. We're talking about moving through all those initial stages, from detection to identification, in just a few seconds. When you're up against a drone zipping along at over 100 miles per hour, you literally have no time to waste.
So, all of this data, detection, tracking, identification, it all flows to one single point. And this is where we get to the most critical, high-stakes moment in the entire chain. This is where cutting-edge technology has to meet human judgment.
This is the human-in-the-loop stage. An operator who's being fed all this information by the system has to make the final call. And they're weighing a ton of factors. How big is the threat really? What do our rules of engagement say we can do? How close are we to civilians? And they're coordinating with the bigger command structure. This isn't a knee-jerk reaction. It's a very calculated choice.
And once that decision is made, the entire kill chain pivots. It shifts from a defensive posture to an offensive one. It is now time to neutralize that threat.
Now, when it comes to actually engaging a drone, there are two totally different philosophies. First, you've got your soft kill options. These don't physically blow the drone up. Instead, they use electronic warfare. You can jam its radio link to the pilot, you can spoof its GPS so it gets lost, or you can even use high-energy lasers or microwaves to silently fry its circuits. Then you have the hard kill approach, which is exactly what it sounds like. We're talking nets, projectiles, other drones designed to intercept, or, of course, classic guns and missiles. The right tool just depends on the situation.
But here's the thing. Neutralizing the drone is not the end of the story. In fact, what happens next might just be one of the most important parts of this whole process.
The final step is to assess and recover. Teams get their hands on the wreckage to figure out what it was carrying and where it came from. They do digital forensics, pulling flight path and telemetry data off its memory chips.
And this is what makes the system so incredibly powerful. Every single engagement is a lesson. All that new intelligence gets fed right back into the system, updating the AI models and the threat databases, so the entire defense gets smarter every single time. It's a perfect feedback loop. But look, this entire kill chain doesn't operate in a silo. For it to be truly effective, it has to be plugged into the very brain of a modern defense network, and that's known as command and control, or C2. This integration is the secret sauce. It's what allows the system to instantly light up the screens of every person who needs to know, from pilots to soldiers on the ground. It coordinates the response across air, land, and even the cyber domain. And it takes all that precious drone detection data and feeds it into the much bigger picture of what's happening on the battlefield. It turns an isolated incident into intelligence for everyone.
Of course, the threat never sits still. The attackers are always working on drones that are faster, harder to see, and smarter. They're even making them work together in autonomous swarms. So, the defense has to evolve even faster.
And this is where the next generation of CUAS is really taking shape. We're now seeing AI that doesn't just spot a drone, but can autonomously triage a whole swarm of them, figuring out which one is the biggest threat. We're seeing models that are designed to predict a swarm's next collective move before it even happens. And with something called edge computing, a lot of this thinking happens right there on the sensor itself, cutting down response times to almost zero. So ultimately, this brings us to a final critical question. This new arms race, it's not just about building better weapons. It's about building faster, smarter decision-making systems. And as we look ahead, the real question is, who's going to win this race? The autonomous swarm or the AI that's being designed to stop it?